Imagine stepping out of your door and immediately feeling a force twice as strong as what you're used to pulling you towards the ground. Welcome to a world where Earth's gravity has doubled, a result of our planet's size increasing twofold. This isn't just a fanciful notion, it's a scientific possibility, grounded in the principles of physics. Gravity, you see, is a direct result of mass. The more massive an object is, the stronger its gravitational pull. So, if we were to double Earth's diameter, we'd be looking at an Earth with 8 times the mass and consequently twice the gravity. Now, that's a significant change. And it's one that would have an immediate and profound impact on life as we know it. With gravity's grip tightened, we'd all feel the weight of this change. Each step would require more effort, and every jump wouldn't lift us quite as high. Even our atmosphere would feel the pull, becoming denser and causing shifts in our weather patterns. And it's not just us. The entire ecosystem would feel the effects of this gravitational increase. Trees would struggle to grow as tall. Animals would have to adapt to carry their increased weight, and even the seas would respond to the pull, with tides reaching new extremes. This stronger gravitational pull would set the stage for a radically different world. But as we'll see, gravity is just the start of the story. This new Earth, twice as large, would present a host of other challenges and opportunities, each more intriguing than the last. In this high-gravity world, every step would be a workout. Imagine the weight of life under the increased gravitational force of an Earth twice its size. All life forms would need to adapt, evolving in ways that ensure their survival in this new environment. Consider the plant kingdom. The towering trees we see today might be replaced by vegetation that is shorter and sturdier, designed to withstand the increased pull of gravity. Branches would be thicker, leaves might be denser, and roots would likely burrow deeper into the earth. The animal kingdom would follow suit. Animals might evolve to be more robust and low to the ground, their bodies adapting to carry the extra weight. The wings of birds would have to be stronger for them to take flight in the heavier atmosphere, and aquatic life might also have to adapt to changes in water pressure caused by the increased gravity. And then there's us, humans. We would likely evolve under these conditions, perhaps becoming a species with a very different physique. Our bodies would have to be stronger, our bones denser. Every physical activity, from the simple act of standing up to more complex tasks, would require more strength and energy. As daunting as these changes might seem, it's essential to remember that life is incredibly resilient. It has adapted to a myriad of conditions throughout Earth's history. Just as life has adapted to Earth's current conditions, so too would it adapt to the conditions of this larger world. The cities of this larger Earth would be a sight to behold. With gravity's grip doubled, our architectural designs would need to undergo a significant transformation. Our tall, towering skyscrapers that scrape the skies might become relics of a bygone era. Instead, we would have to build wider, sturdier structures to withstand the increased gravitational forces. These robust structures would sprawl across the expansive landscapes, creating a new kind of cityscape. The challenge wouldn't just be about standing tall, but standing strong. Engineers would need to get creative, finding ways to balance architectural beauty with the brute force of gravity. The materials we use, the shapes we design, and the way we construct our buildings would all need to adapt. This would be a world where the horizontal rules, where breadth takes precedence over height. In this larger world, we would need to rethink our approach to construction and design. Beneath our feet, the Earth would be rumbling with increased activity. A planet twice as large would hold a greater mass, and with this mass comes a surge in geological dynamism. Imagine, if you will, a world where the ground beneath us is more alive, more restless. With such an increase in size, the Earth's volcanic activity would intensify. Those silent, sleeping giants we know as dormant volcanoes might awaken, rumbling back to life as they respond to the inner stirrings of our larger planet. The surface, our familiar home, could be reshaped by these powerful forces beneath, etching new patterns and contours into the landscape. This geological upheaval would not be a quiet process. It would roar and rumble, spewing forth new landforms from the fiery depths. This larger Earth would not only look different on the surface, but also beneath it. This larger Earth would have a face that's familiar, yet vastly different. Picture the continents, the familiar outlines that we've come to know, shifting and changing due to the increased volcanic activity. As volcanoes erupt, new landforms would be created, reshaping the world map as we know it. The vast landscapes would bear the marks of nature's power and might, a testament to the dynamic forces at play beneath the surface. But it's not just about the land. The distribution of water would likely change as well. Oceans could shift, lakes could form where none existed before, and the currents that drive our climate could take on new patterns. These changes could lead to new weather phenomena, altering the climates we're accustomed to. Imagine tropical rains in what was once arid land, or Arctic winds sweeping across previously temperate zones. The map of this larger world would be a testament to the power of nature and the adaptability of life. This larger Earth would be a bigger target in the cosmic shooting gallery. You see, size matters in the universe, especially when it comes to gravitational pull. A planet twice the size of our current Earth would have a stronger gravitational force, acting like a celestial magnet. This means it would attract more space debris, including asteroids. The potential for asteroid impacts would increase substantially. And we're not just talking about small, harmless meteor showers here. We're talking about the big, city-destroying kind of asteroids. These catastrophic impacts could drastically alter the planet's climate, triggering what scientists call an impact winter. That's a period of profound cold, darkness, and reduced photosynthesis that could last for months, even years. The larger Earth's stronger gravitational field would also pull in larger asteroids, further escalating the risk. So in this larger world, the sky might not be as friendly. The changes wouldn't stop at the Earth's surface. With a larger Earth, we'd be looking at a set of cosmic dominoes on the brink of tipping. The first domino? Our planet's orbit. A larger Earth would travel along a different path around the Sun, potentially leading to longer or shorter years, and drastic shifts in our seasons. Next up would be the Moon. Our bigger Earth would exert a stronger gravitational pull, affecting the Moon's orbit, and in turn influencing our tides. Imagine oceans swelling and receding in entirely new patterns, creating a world where high tide is a whole new ballgame. And let's not forget our neighbors in the solar system. The gravitational dance between Earth and the other planets would shift, altering their orbits and possibly causing a ripple effect of changes throughout the solar system. This larger Earth would leave its mark on the entire solar system. In this larger world, life as we know it would be vastly different. We've journeyed through a hypothetical Earth twice the size of our own, grappling with a gravitational force twice as strong. We've envisioned the evolution of life and architecture under this increased pull, and pondered the geological upheavals that would reshape the planet's surface. We've imagined a new map marked by increased volcanic activity, and contemplated the heightened risk of space hazards due to a stronger gravitational pull. This thought experiment takes us beyond the surface, exploring the ripple effects a larger Earth might have on the dynamics of our entire solar system.